Example 2, determining concavity again. Determine the open intervals on which the graph of f of x is concave upwards or concave down. And we're going to find the points of inflection if there are any. Again, I'm giving you a nice hint here. First, find the domain. So, as long as this is not equal to 0, we're good. The denominator. So the domain is going to be from negative infinity to negative 2. Because if I plug in negative 2 here, negative 2 squared minus 4, that would equal 0. Union from negative 2 to 2. Union from 2 to infinity. So again, as long as x is not negative 2 or 2, it meets the demands for the domain of this function. Alright, so now let's find the first derivative. So this is going to be the quotient rule. So it's going to be the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. So we got that to start. Now the numerator I'm going to multiply here. So this is going to be 2x cubed minus 8x minus, multiply here, this is going to be 2x cubed plus 2x all over the denominator, which is x squared minus 4 squared. So now notice that 2x cubed minus 2x cubed, that would be 0. And negative 8x minus 2x would be negative 10x all over x squared minus 4 squared. Now let's do the second derivative. Again, this is going to be the quotient rule. So it's going to be the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, which would be 2x squared minus 4 to the first power times chain rule 2x all over x squared minus 4 to the fourth power. You're going to square what I did there. I squared the denominator. Okay, so now let's simplify this. Let's see, so I've got negative 10 times x squared minus 4 squared plus, let's see, that's going to be plus 10x times 2 times 2x is going to be 40x squared, x squared minus 4 to the first power all over x squared minus 4 to the fourth power. Now, right here, I can factor out, or cancel that out actually. So now f double prime of x equals negative 10 times x squared minus 4 plus 40x squared all over x squared minus 4 to the third power. Then the numerator I can distribute, so negative 10x squared plus 40 plus 40x squared all over x squared minus 4 cubed. Then this is going to be 30x squared plus 40 all over x squared minus 4 cubed. And then here I can factor out 10, leaving me with 3x squared plus 4 all over x squared minus 4 cubed. So now, to figure out possible points of inflection, I need to figure out x values where the second derivative is equal to 0 and where the second derivative does not exist. So if I look at the numerator here, is there anything that I could plug in for x that would make that equal to 0? Because if the numerator is equal to 0, then that's where the second derivative would equal to 0. Nothing there. Look at the denominator. Are there x values that would make the denominator equal to 0? Because if there are, then that is where this second derivative would not exist. Here there is. We'd have a possible point at an inflection at 2 and negative 2. Now, those are definitely not going to be points of inflection because those points don't exist on the domain. But we still have to figure out the open intervals where it's concave up and concave down. So again, the points don't exist at negative 2 and 2. We need to check each of these intervals for concavity. So here, let's check f double prime negative 3. Here let's check f double prime of 0. And here let's check f double prime of 3. So, numerator, no matter what you pick, it's going to be positive. The denominator, when this is negative 3, that's going to be 9. 9 minus 4 is positive, so that's going to be positive. So this would be greater than 0. So this is going to be concave up on that interval. Let's see about 0. That's still going to be positive. This would be negative when that's the case. So this is going to be concave down. So concave up, concave down. Remember, that's not a point of inflection because the point doesn't exist even though concavity changes. And then 3, okay, numerator would be positive. This is going to be 9 minus 4, which would be positive. Cube of positive, still a positive. So this is going to be greater than 0, so this would be concave that would be it for this one.